All right. So you had a homework due this past week. I'm just going to go through the solutions here and show you how to do it. Okay. So question one says that there is a market for healthcare where people must buy their healthcare from others. This seems pretty true for the real world. So the demand equation is given by P is equal to 100 minus 2Q. And the supply equation is given by P is equal to 10 plus Q. Now we could turn these into an equation that says Q is a function of price pretty easily if we wanted to. Okay, so through some algebra, what you would end up with here would be Q is equal to 50 minus 1/2 P. And this would turn into Q is equal to P minus 10. In this form, it's useful to have this form written down in some instances, just because for the most part, we typically think that people respond to changes in price. And so the amount that we purchase is a function of how much it costs, rather than the price being a function of how much is bought. Okay? Either one's perfectly fine. Algebraically, they are the same. Having it in terms of as a function of Q, so having P is equal to some function of Q, makes it easy if we wanted to graph this. So if we did, it's much easier to use this form just because we're more familiar with graphing when we have things in terms of whatever's on the y-axis. So here, it'd be 100 and then 50. All right, so we can connect these endpoints. That would be our demand curve. For supply, we would start at 10 and we would slope up with a slope of 1. And so what we're after is what this point is here. Okay, so I'm going to use the P equals a function of Q form. You can do it with Q equals a function of P, and you're going to get the same answer either way. So to solve this, we just set these equal to each other. And we say 100 minus 2Q, that must be equal to 10 plus Q. We're going to add 2Q to both sides, and we're going to subtract 10 from both sides to get the numbers over here and the Q over here. So that'll give me 90 is equal to 3Q, which means that the quantity is equal to 30. Okay, so we can put that in. And now we want the P. So what we can do here is we can just sub this in to either equation. I'm going to sub it into both. Subbing it into both is an easy way to check and make sure that you've solved everything, because you should get the same price no matter where you plug it in. So let's just do it real quick. So we'll start with the easy one. P is equal to 10 plus Q, right? But Q is equal to 30, and that means it's 40. The other one up here is still easy. P is equal to 100 minus 2 times the quantity 30. And that's equal to 100 minus 60. And that's also equal to 40. Okay, so here we can be pretty confident that at our equilibrium, the price is 40 and the quantity is 30. Okay, so let's go on to question 2. So question 2 just says that the demand increases, the quantity stays the same. And so in this case, the demand is going to increase to 130 minus 2Q. Okay, we can do that. Let's just erase all of that. 130. Now let's go ahead and graph it just so we can see what we're doing. So I'll use a different color marker. So all we've done is we've shifted the demand curve to the right. So our new intercept is up here at 130, and our new x-intercept, or q-intercept, is going to be at 65. So let's just draw that. That's our second demand curve. And so what we're after is going to be this. Okay, we can solve it the exact same way. So 130 minus 2Q is equal to 10 plus Q. Okay, we're going to do exactly the same thing. We'll add 2Q to both sides. We'll subtract 10 from both sides. So that should give me 120 is equal to 3Q. and that means that Q is equal to 40. Okay, so we've got that number here, and then we'll just take this right here, and we'll plug it in here, and we'll plug it in here. Okay, so let's start with this one since it's easy. P is equal to 10 plus the quantity. In this case, it's 40, and that's equal to 50. And for the demand equation, P is equal to 130 minus 2 times the quantity 40, which is equal to 130 minus 80, which is also equal to 50. So we can be fairly confident that the equilibrium price in this example is going to be 50, and the equilibrium quantity is going to be 40. Okay, so now what we're going to suggest, or what we're going to do, is we're going to suppose that question 3, the increase in price from the last question, so going from 40 to 50, is deemed immoral by the local media and the elected officials. After all, what kind of just system would allow doctors and hospitals to take advantage of the increased needs of people by charging them higher prices in their times of need? To combat this, a new law is passed with unanimous and bipartisan support that explicitly bans hospitals and doctors from increasing their prices, and also bans them from changing any characteristics about how they provide care. So for example, doctors and hospitals cannot change how they actually deliver the care by perhaps shortening the appointment slots, having nurses visit patients instead of doctors, etc. So there's no difference in terms of what actually happens. But we have kind of a quandary here, okay? The law says the price is not allowed to change, so I am going to say, or just draw that with a red line. For those of you that have taken microeconomics, this would be a price ceiling. Okay, it's a legal maximum on the price. And so the question is going to become, what is going to be the quantity demand and what is going to be the quantity supplied? Well, we already know the quantity supplied, right? Because we solved it in our very first problem. So we know the quantity supplied is going to be equal to 30, right? And we can solve that real easily by noting, so I'm going to get rid of all of this algebra here. We can solve this, we can know it intuitively if we have the graph here and we know kind of what's going on in the background. But we can solve it, so we know that the price must equal 40, okay? And so the question then becomes, what quantity would make this equation true if P is equal to 40? Okay, so 40 is equal to 10 plus some number. Okay, we don't know what that number is. Well, we do, but we can show you how to do this. We'll just subtract both 10 from both sides, and that means 30 is equal to quantity. Okay, in this case, it's quantity supplied, because we're talking about the supply curve. But what about the quantity demanded? Okay, so again, we know that P is equal to 40. So I've got to find a quantity that's going to make this equation true. So I need 40 to be equal to 130 minus 2Q. We can solve this pretty quickly, so let's just divide both sides by 2 just to get rid of this coefficient here. Okay, so 20 is equal to 130 divided by 2. That should be 65. And half of 2Q is just Q. Okay, let's add Q to both sides. So 20 plus some quantity is equal to 65. Subtract 20, and that means Q is equal to 45. So the quantity demanded is 45. All right, and we know that's the quantity demand because this Q came from the demand equation. So this will be the quantity demanded. Now this seems slightly problematic because we have 45 units of healthcare. If you want to think of these as doctor's visits, you can think of it that way. We have 45 people that wish to see the doctor, but we have 30 appointments. That's problematic because there's more people that want medical care than medical care that exists. That sounds like a problem.